This slide shows some part of the systems. The first collection tank, we have a drum screw filter, the screw filter that we have used, and the skid that we have proposed. In this case, it was pretty important to us to guarantee a compact solution, and that's the reason why we choose the plate heat exchanger, and economic solution, because you will see later on the number of working hours and the flow of the system was not big enough to have a good payback with the pipe shell heat exchangers. So we prefer to add the screw filters in both sides in order to guarantee the plate heat exchanger that we have actually used. And in this case, particular case, both sides of the heat exchanger are cleaned by chemical systems. This slide shows the return of investment calculation. We started from the steam cost that the company was paying. It was around 25 US dollar per megacalories. And then we added 3.9 US dollar per megacalories, which are more related to the pump consumption of the thermal oil. You must consider that in this situation, the boiler was used in order to warm up the temperature of thermal oil. And with the thermal oil was the fluid designed to warm the temperature of the water in the washing machine. So if you use the thermal oil, you must consider also the power of the pumps, and also the power of all issues, all objects which you need in order to treat the exhaust of the boilers. We made the calculation according to the real consumption, and we added 3.9 US dollar per megacalorie for those objects. So the final consumption, it was around 28, almost 29 US dollar per megacalorie. The electrical cost we have considered in our return of investment calculation was 7 US dollar cent per kilowatt hour. And the wastewater temperature in the origin for the first reading was 60 degrees, and the reusable water average temperature was 35 degrees. Finally, the flow, it was around 6 cubic meter per hour. This was a problem for us because, as I told you, our system works much better and can pay back itself much better if the flow is higher than this. But anyway, we found a solution that was acceptable for the customer, which accepted, of course, a longer payback time in order to be more environmental friendly. And finally, the working hours per year, which were just almost 5,000. So those were the base of our calculation. And over here, you can find the saving. Of course, the saving is mainly related to the thermal energy that you can save because you have warmed out the temperature of the second and the third rinsing, so the reusable water from 35 degrees to 58 degrees. Of course, you have to multiply such a difference by 6,000 liters per hour, and the number of hours per year, which are almost 5,000. And so you can have 681,000 megacalories per year. If you multiply this amount by the cost of each megacalorie, you will find a final saving of 19,613 US dollar per year. Of course, this is the saving, is a gross saving, because to be fair, you must reduce such cost considering the acid cost and the electrical cost related to the extra pumps that we have installed on our skid. So the final saving has been just 18,500 US dollar. The investment cost was almost 115,000 US dollar, everything included. It means also the installation cost is, and so the payback time, it was 6.2 years. The customer has decided to make this project not only because of the saving, which is pretty good, I believe, because 6 years is not so much in terms of time if you consider that the flow was not so big, but even because, as I told you before, it was obliged to make to build up even a cooling tower. Without this cooling tower, it saved some money also because it didn't do the investment and all the running costs is related to it. We didn't consider such kind of expensive in our return of investment calculation in order to be on the safety side. But if you consider also those costs, the real payback time drop around little bit less than 5 years. So anyhow, it was a good investment for them, and they have decided to do that. This is an example of what you can do with a batch machines, which is normally more costly if you compare it with a continuous machine, because of course you need to prepare some infrastructure with all the collection tanks that I showed you before. Of course, when you go to a continuous machine, the investment cost drops, and normally the payback time drops as well because the infrastructure is not necessary anymore. This slide shows a washing machine, which is a continuous machine. Continuous machine is a machine that requires fresh water in the same moment that is discharging wastewater. So you don't need to collect the fresh water and the wastewater, and you can go directly to the wastewater heat exchanger. So in this case, it's very easy to be applied. The system is very easy to be applied, and actually the cost and the payback time it's completely different compared to the scenario that we have seen before. So this was done in Vietnam as well, in an Italian factory that is one of our customers in Vietnam, in Nguyen Nguyen provinces. The machine was discharging at 8 degrees, and the cold, clean water was filled up at 25 degrees. And of course, in order to reach the temperature required by the recipe, they used to have a steam, normal steam. After the heat exchanger installation, the washing machine discharge was, of course, always 80 degrees, but by using the heat exchanger, this temperature dropped to 33 degrees before going to the wastewater treatment. And on the other hand, the fresh water was raised by 25 degrees to 72 degrees. Of course, with such hot temperature in the fresh water, the consumption of the steam, it was significantly reduced with a big savings in terms of money. So the steam consumption before the intervention, it was around 1.2 tons per hour. And the steam cost in the factory was 23.76 US dollar per ton. The hot wastewater temperature, it was 80 degrees. The cold water average temperature was almost 25. In this case, the flow was much higher than before. It was around 11 hours per day, where 3,160. In order to have the saving, it's quite easy. I mean, you have to multiply the differential temperature between the wastewater 80 degrees and the fresh water incoming 25 degrees by the number of liters and by the efficiency guaranteed in our system, which is at least 86%. Dividing such number by 600 calories per kilogram of steam, you will find out how many kilograms of steam per hour you can save, which is around 867. If you multiply this number by the number of hours, working hours per year, and of course, dividing by 1,000 kilogram, which is in order to reach the ton. And if you multiply this number by the price of each ton of steam, you will find easily your saving, which is 65,000 US dollar per year. With an investment cost of 78,500 US dollar, your payback time will be around 1.2 years. In this slide, we didn't show you the price of the chemicals and the price of the pump, but if you remember the last one, those numbers will not affect so much the payback time, which would be anyway very interesting, let's say 1.3, 1.4 years. So anyway, it will be very interesting. Was because in this case, the factory we're talking about is using mainly synthetic processes, and all this washing machine was applied after dyeing. So in this case, the number of chemical used is completely different, and so the chemical procedure in our system will be used not so often as before. So it's going to affect the final numbers even less than before. This is another solution that can be applied by energy efficiency consultant, which is much more related with the machine choice. As we have discussed before, we strongly believe in the partnership that has to be created between the efficiency consultant and the final customer. It means that, according to us, energy efficiency consultant should be involved not only in the services, but also, if it's possible, in the machine decision. Just to give you an example, when you print, if you make a digital printing, after it, you must wash your fabric, okay? Actually, the whole technology, which is pretty common, especially in the East, in Vietnam as well, is using the Benet machine. Benet machine is a batch machine, is like a big vessel. You put your fabric in this vessel and you fill it with fresh water for a lot of time in order to remove the residual dye stuff that are inside your fabric. We did some calculation for a customer, and we didn't do the investment yet, but we strongly believe that is going to be done very soon. The water consumption with such technology is around 931 liters per kilogram of fabric. If you use a new machine, which is continuous one, it's something that is pretty common in Italy, but not just in Italy, almost everywhere. The water consumption drops to 35 liters per kilograms. So can you easily imagine how much it could be the saving in terms of water, steam, and wastewater treatment cost? Actually, sometimes your customer take the decision to go with the old technology just because maybe it's more trustable, because he prefer to stay on the safety side, because he doesn't want to have problems in terms of quality. On the other hand, somehow it cannot easily understand which is the weight of his decision. I mean, which are the costs related with such a decision. Really, it's not just related to the energy efficiency, but also with the water consumption. I mean, 931 liters per kilograms, it's a big amount, a huge amount of water compared to the 35, which is the benchmark of such kind of activity. So in Europe, we usually have some literature in order to give us some advice and some support when we try to find out the best technology, which is called BAT, BAT means best available technology, are made by European Union. There are many commissions to do that. So if you look at them, you can easily find out which is the best solution for each single process. I don't know if you have such kind of stuff in Asia, but according to my experience, I didn't find in Vietnam such kind of literature. So we believe that when you want to go to a textile factory, it would be pretty important to have a general knowledge about such kind of literature. You can easily find out even via internet. I mean, they are pretty common and can help you to define with your customer which it will be the best technology. It's according to us pretty important to try to convince your customers that sometimes they have to take some risk, maybe have some trials and try to define the best machine in order to consume as less as possible. The water in Vietnam is pretty expensive. In Italy, we have water almost for free, especially if you have wells. But according to my experience in Vietnam, water is pretty expensive, especially the wastewater treatment cost is pretty high. On the other hand, we didn't mention it over here, but you have also to consider the chemical consumption, which is basically related to the water. So we believe that the right machine, and this is just a very simple example. The other one, it will be a little bit more complicated, but we strongly believe that it's pretty important to convince your customer to share with you not just the services, but also machine technology as much as you can. This one shows a different type of machine, which is the dyeing machine for cones or bobbins. In order to better explain you how this machine works, we need to understand how it works, the dyeing procedure. Of course, we don't have a time to go into this technology so deeply, but let me give you just a roughly idea of what the machine does. Normally, this machine is filled by fresh water. You can have a different type of machine that could be fully flooded or air pad system. Fully flooded means that the machine should be pressurized by water directly, and so all the oxygen inside, all the air inside the machine is replaced by water and pressurized by a pressurizing pump. The air pad system, it's a system that is more modern, and it's normally used when you have reactive dye stuff. Because if you wanted to go with bad dye stuff, which is mainly used for shorting, you cannot have oxygen inside your machine, so you are somehow obliged to go on the fully flooded mode. In the air pad system, you must pressurize your gear, your device, by using compressed air instead of water. And in this way, the liquid ratio, which is the ratio between the number of liters of water and the kilograms of your bobbins, so the kilograms of your yarn, can drop for 1/10, which is the normal solution with a fully flooded system, to 1/8. In this case, the consumption during your dyeing procedure, the electrical consumption is around, normally when everything goes well, 1 kilowatt hour per kilogram, and the thermal consumption has to be around 15 kilowatt hour per kilogram. Why we need to fill the machine up to 1/8 liquid ratio? This is because during the procedure, the pumps reverse its flow from internal to external and external to internal. So if you wanted to leave the water goes from external to internal, like in this picture, the level of the water must cover the last bobbin in your spindle. If you look at the new procedure that many final customer are asking for, like Burberry or big customer like Zara Group. They are now asking and pushing their own supplier in order to go with machines able to have a liquid ratio lower than 1/7. How they can do that? It's shown in the next slide. It's mainly related to the fact that the flow is not reversed. So in those kind of machine, which is called pulse wave dyeing, the flow goes always from internal to external and is not reversed from external to internal. In this case, the liquid ratio could be even lower, so just 1/5. And of course, your electrical consumption will drop from 1 to 0.7, and accordingly, the thermal consumption can be dropped from 15 to 8/10 kilowatt per hour. This kind of technology is, I believe, the most modern one, and it's now used by almost every big suppliers of a dyeing machine. So we're talking about Fonx in China and Bellini in Italy, or Thiess in Germany. All of them are now developing such kind of technology, even that to be honest, this kind of procedure cannot be used for every kind of dye stuff, has to be kept just for reactive, according to me, and according to my experience, can be just used on the easy colors. When the colors are dye stuff are tough, like orange, like some pink, colors that are very difficult to be solved in the water, this technology cannot be used because the final quality will be affected by many small defects, which are made by, let's call them dot, okay, on the fabric, and so the final color will be not so uniform. But anyhow, I believe that this is the future in something we should look at with of course the suppliers of the dye machine. We made some tests in Albini because of course this is something that cannot be sold to a final customers without making internal tests to be sure that it goes in the right direction. But according to me, this is something to look at very carefully, and I'm pretty sure that is going to become the next benchmark for the future. Maybe easy to understand, but anyway, where I've noted that people didn't care too much about it. I mean, the connection between the big pipes, the manifolds, and your machines. If you put small pipes, especially on the water lines, hot water, cold water lines, if you put small pipes on the steam, you are going to need more time to fill the machine, to warm the machine, and to reduce the temperature inside the machine. So basically, your cycle, your dyeing procedure is going to take much more time. It means that it's going to take much more in terms of costs because your circulation pumps is running anytime. So if your dyeing procedure takes 8 hours, the main pumps will run 8 hours. If it takes 6 hours, it runs 6 hours. It means that at the end, the electrical costs will be split, will be more or less in relation of based on the duration of your cycle. So it's pretty important to define, to design the right connection between your manifold, all the pipelines basically. So the connection between your system pump to the dye house and from the manifold to all the machines. We have done a calculation. Unfortunately, we cannot share all the curves with you because, as you can imagine, it's something very private for the customers, but the customer we have worked with gave to us all the curves of the thermal procedure and the chemical procedure. So according to all those diagrams, we were able to calculate the time that they lost waiting for fulfill the machine, drain the machine, heat the machine, reduce the temperature inside it. And so at the end, the final cost just related to the mistake that they have done in the connection of the machine could be calculated in almost 30,000 US dollar. So if you change all the pipes in this dyed house, it means be ready to pay 120,000 US dollar. The payback time, it would be eventually a little bit more than 4 years. So this is just to give it to you an example of how important is to design the mechanical distribution for all fluids in the dye house and finishing, generally speaking, for the textile, because a mistake on such part of the project is going to affect the running costs of your customer